So in this video, we're going to talk about how to calculate formal charges. And the idea here that I want to bring in is we need to first be able to read the periodic table. Right? So the reason why the periodic table is important is that we're going to talk about some of the things that some of the trends that we actually need to calculate formal charges. And so we say that the first column of the periodic table, everything in this column possess about 1 valence electron. Everything in this column presents about 2 valence electrons, 3 valence electrons, 4, 5, and you can kind of see the trend here, right? And then noble gases finally have 8 valence electrons. The reason why we need to know this is that the formula says that pertaining to whatever atom that we're talking about, we need to know how many valence electrons does it have. So let's talk about how to calculate formal charges. So let's say on an exam, you're given this structure. And let's say that you're also given this structure. And you're asked to calculate the formal charge of each individual atom, right? Well, right now, as you could speak, we know that hydrogen usually don't calculate formal charges for hydrogen. It just doesn't happen. However, we can calculate the formal charges of nitrogen and carbon. So before we do that, we need to know what is the formal charge formula. And there's a specific formula in you guys' books that's like 1/2 bonding electrons minus like non-bonding electrons or something like that. That's the official formula. Here we're going to use a shortcut formula. And so the shortcut formula says that we take the number of valence electrons, right? So we take the number of valence electrons of the atom of interest minus the total number of electrons around the atom of interest. Total number of electrons around atom. So this is how we define a formal charge in our definition, and we're going to do some examples. So let's say we want to calculate the formal charge of this carbon. Now, one thing I may remind you in organic chemistry is that we do not always explicitly state the lone pairs. Right? So we have to do a little bit of inference here. Now remember, I'm looking at a formula, I'm looking at a Lewis structure that there are no charges. So that means that this essentially has to be neutral. Right? So what does that mean? Well, if the overall molecular formula, the Lewis structure has to be neutral, well, in this case, if we're doing the Lewis structure for carbon, the formal charge for carbon, the formal charge for carbon in this case would be 4 valence electron, right? Because remember that carbon has 4 valence electrons. So this is what the first part of the formula says, the number of valence electrons of the atom of interest. Right? So carbon has 4 valence electrons, and we simply just get that from the periodic table. And we subtract that from the total number of electrons around the atom. Now this is where it gets tricky. When we say the total number of electrons around the atom, we're actually talking about the electrons that is pertaining to only the atom. So for example, let's look at this. A single bond consists of 2 electrons, one from the hydrogen, one from the carbon in this case. The same thing is also true for this bond, right? One from the carbon, one from the hydrogen. The same thing is also true for this double bond. We have 2 that pertains to the carbon, and we have 2 that pertains to the nitrogen. We only care about the electrons that are pertaining to the carbon. So that means that I'm not going to count the electron that pertain to the nitrogen or the hydrogen, right? So if I draw a dotted circle, you could see that the electrons that I'm counting is explicitly pertains to the carbon. So everything inside that box would be what I'd be counting. So in this case, I have 1, 2, 3, 4 electrons in there, right? And so in this case, that would be 4 minus 4, which would be 0, right? And so this carbon here is actually neutral. How about this nitrogen, right? Well, I'm going to take my formal charge. That is going to equal to now 5 electrons. I get that from the periodic table because nitrogen has 5 valence electrons. Now the total number of electrons that pertains to the nitrogen of interest, well, I have 2 that's from this nitrogen, and I have 2 that only pertains to this nitrogen. Now if I draw a circle around it, everything inside that circle is what we really care about, right? Even though there are 2 other electrons that pertain to this nitrogen, and let me do it in green, that pertains to this nitrogen, we do not count it because we're looking at this nitrogen, right? So in other words, this would be 5 minus 4, and this would actually be a plus 1. So we say that the formal charge in this nitrogen is actually plus 1. Now, how about this nitrogen? Well, be careful. Remember we said that the overall charge of the molecule is neutral because we did not see any charges, right? Now, remember that lone pairs are not always explicitly stated. So if this is 2 valence electrons, if this is 2, if this is 1, 2 from the nitrogen, right? Remember, in Lewis structures, we have to satisfy the octet rule. So in total, we actually have 4 valence electrons around this nitrogen, right? So that means that there must be 2 additional pairs of lone pairs around the nitrogen. Why? Because now I have 2, 4, 6, 8. So this will actually satisfy the octet rule. And so this is where the lone pairs, you have to be careful in organic chemistry to know that lone pairs are not always explicitly stated. So going with what we know, from here, we know that the formal charge of this nitrogen now would actually be 5 electrons, right? From the nitrogen, from the fact that it's nitrogen, we get that from the periodic table, right? And now how many electrons we have total around it? Well, look, we have 2, 4, 6. So this is 5 minus 6, and that's actually a negative 1. So this nitrogen actually have a negative 1 formal charge. How about over here, right? How about this carbon? Well, be careful. Again, we do not see any charges, right? So there are no charges, right? And carbon at this point only has 2, 4, 6 valence electrons around it. Now that doesn't make any sense, right? It doesn't make any sense that it has 6 valence electrons around it because that's not how we write. That's not how we write Lewis structures. They have to satisfy the octet rule. So in other words, it is implied that 2 pairs of lone pairs actually on this carbon, because look, now we have 2, 4, 6, 8 electrons around the carbon. So first we didn't show it, the lone pairs, but now we have to make sure the lone pairs are there in order to get the correct formal charge on the atom, right? So in this case, the formal charge would be equal to 4 electrons from the fact that it's just carbon minus, well, look, be careful again, the total number of electrons that only pertains to the carbon, right? So I have 1 here, right? Remember, a single bond consists of 2 electrons, 1 from the carbon in this case, 1 from the hydrogen. It's the same thing here, 1 from the carbon, 1 from the hydrogen. And it's the same thing here, 1 from the carbon, 1 from the nitrogen. Now, how many total electrons do we have around the carbon that's only pertaining to the carbon? If we draw a circle, and you don't have to do this to draw a circle, but it's just for illustration purposes. Once you start doing it with practice, you kind of see this on your own. Now, this becomes, how many electrons do we have in the circle? 1, 2, 3, 4, 5. So this is 4 minus 5, and we get this to be a negative 1. Right? So we say that this carbon is actually negatively charged. How about this nitrogen? How about this nitrogen? What would you say the formal charge is? Well, in this case, the formal charge is equal to 5 electrons just based on the fact that it's nitrogen minus, well, I have 1 electron here. Now remember, even though this is a triple bond, and we say a triple bond consists of total 6 electrons, we're only talking about the nitrogen, the electrons that's only pertaining to the nitrogen. So in this case, if we draw a circle, what we're really looking at is actually 4 electrons, right? And so this will equal to a plus 1 formal charge. So we say that the formal charge on this nitrogen is actually plus 1. Pause the video and do this. Pause the video and do this nitrogen, and you'll actually see that it's neutral. right? Why? Because remember that again, we do not see any charges, so we know that the overall charge of the molecule has to be neutral. And so two lone pairs have to be at this nitrogen. Again, remember in organic chemistry, the lone pairs are not always explicitly stated. So if we do the formal charge, this becomes 5 electrons just based off the fact that it's nitrogen. And then I have 1, 2, 3, 4, 5. So if I draw a circle, what's inside the circle is 5 electrons. So 5 minus 5 is actually 0. And so we can actually see that this nitrogen is actually neutrally charged. Now notice that the overall charge of the molecule is still 0, right? A positive plus a negative is 0. And these are what we actually call resonance structures. Right? These are what we call resonance structure. Reason being is that we're only moving electrons. We're not moving any atom around. We're not changing the bonding pattern. Well, the bonding pattern may change, like for example, from a double bond to a triple bond. But the idea is that we're not rearranging the atoms themselves. What we're doing is just moving electrons.